Okay. So yes, thank you for coming to Spring into Research 2023. We're happy to have y'all. I've put in the chat the link to the LibGuide with all the sessions that we've got upcoming this week. So definitely register for additional sessions if you haven't already. We'd love to have you. But today we have Brent Peterson here today. He works in our DigiLab, the Digital Humanities Lab at the main library here at the University of Georgia. And he's going to be talking about an introduction to the command line. So thank you, Brent, for being part of the session this year. We appreciate it.
Yeah, thank you, Diana.
Okay.
No, looks like we have a bunch of numbers wanting to come into the chat. Hopefully, they're a good aligned bunch of numbers. I rolled the dice on them. I think they're fine. All right. So welcome everybody to Intro to the Command Line. Happy spring. Yesterday was the vernal equinox, and hopefully we can give some rebirth to our learning energy today. This will be a brief introduction to the Unix and Linux command line. So hopefully either you're using a Mac machine or some variety of Linux. You can also use various programs in order to mimic the Unix Linux command line in Windows, and I'll go over that in a second. But let's begin. So getting to the command line, if you're a Mac user, you can enter the terminal, which is where your command line lives, in Spotlight Search, which is this little magnifying glass up here. You can just type terminal and get to it. I've already opened mine, so I'm not going to do that. You can also get to Spotlight Search by just pressing Command plus the space bar. It goes like that. It also goes away if you press it again. If you're a Linux user, you probably already know this since it takes a little bit of doing in order to install Linux. But if you don't, in Ubuntu, you can use Control-Alt+T. And in GNOME, you use Alt plus F2. There's also some GUI options in various Linux varieties, but those are less fun. And again, if you've installed Linux, you probably are more likely to use the, command options anyway. All right. So if you are using Windows, don't despair. You still can follow along. You'll just need to download and install the Cygwin program, and that's at cygwin.com. I would put that in the chat, but I'm pretty sure you can type cygwin.com in. And then when we're doing file structures, I don't think we'll actually get to any file structure stuff, but if we do, the file structures I have will be forward-facing slashes, but for Windows users, they will be left-facing slashes. All right, I'll leave that up for just a second. Cygwin.com, Windows user. Don't know if anyone is a Windows user. No shame if you are. All right, so let's go to the actual terminal, and I have one up from myself. So I'm not going to do the spotlight thing. And this is where the magic happens. I'm going to have the terminal up along with my PowerPoint through this. And what the terminal is here is the usually either bash, which is the Bourne Again shell, or ZSH. So Mac users will automatically be in ZSH. But Linux users typically get bash or Bourne Again shell. You can switch to bash on Mac by typing bash. I'm actually already in bash here, but I can go to ZSH and get that as well, which is again the sort of standard thing. There are differences, but I wouldn't worry about them now. I'll just stay in ZSH. Looks like there's something in the chat. All right, yeah. So David, I would try to download that. You can try to follow along a little bit, but if you're in Windows, I would get the Cygwin and see if you can start following along there. All right. So, like I said, there are differences, but it really shouldn't matter for now. We are not going to be messing with anything that's that complex. So the first thing, we're going to start at the very beginning, which is a very good place to start. And the very beginning that we'll be starting at is literally Genesis, which means beginning or origin in Greek. So I'm going to be putting this in the chat. Let's see. And actually, let's make sure that, let's briefly get this and put it in the chat, because I actually had this in my clipboard, but somehow I ended up doing something else and it's not there anymore. But here you go. Get that in the chat, and it should be in your downloads when you have gotten it. Let's get back to the reading view here. And it looks like somebody just entered. And for that person, I'm going to put this in the shell again, in the chat again. So please download the genesis.txt file in the chat. And then open a terminal or a whatever you have on your machine. So the first thing that we're going to do now that we have a terminal open on our respective machines is we're going to learn how to list files in a directory. So when you start out in the command line or in a terminal, wherever you want in this bash or bourne again shell or ZSH, you most likely will go to your home directory. And my home directory is entitled Brent. You can see that here. So Brent at MacBook Pro. So MacBook Pro is my machine. Brent is my home directory and my username. And the way that you see the files in your current directory is by typing ls. So you can see that my home directory is ridiculously clogged and has a bunch of stuff in it. So, type that in your terminal, see what comes up. You should be able to see all of your files in your home directory. If you want to know what directory in, you can print working directory, for short PWD. And this says users/Brent, which is my home directory. So we are going to be using the genesis.txt file you just downloaded. In order to use it, we're going to probably need to go to the directory it's in, and you just downloaded it, so it should probably be in your downloads. If you're a savvy downloader and you put it somewhere else, then you'll need to use this next command in order to go there rather than downloads. But for those of us that put it in our downloads, we can type cd, which means change directory, and downloads. And then to make sure that we're in downloads, even though you'll probably see it to the left in your terminal, we can type pwd again, print working directory, and we'll see that we're in our home user downloads directory. So if we want to remove genesis.txt from our downloads folder and put it in our home folder, which we might want to do, you can type mv and then the name of the file, genesis.txt, and then this tilde. And the tilde specifies your home directory. And again, mv means move. So what we're doing is we're moving genesis.txt to the tilde, which stands for our home directory. And you won't get any sort of confirmation of this once you do it. Once you press enter, it will simply go to the next line. And this has a tendency to be what happens in using the command line. It won't tell you that you just did something. It just won't give you any sort of error. So if you type cd by itself, it will actually take you back to your home directory, which is where genesis.txt should now live. If we want to see the beginning contents, so the beginning of the beginning, we can type head genesis.txt, and we can see the very beginning of the beginning. If you want to see the end of our little Genesis fragment, we can type tail genesis.txt. And that will give you this tail end of Genesis. This is not the end of Genesis because I did not put all of Genesis in this file. I just put a fragment. So one thing that you might want to do with text, if you're working with text, which is what this is presupposing, this workshop is presupposing, is get a frequency count. So a frequency count is the number of times individual words appear in your text or corpus. So what we're going to do is we're going to start out guns blazing, and we are going to just type this whole monstrosity of a command into our command line. Now, there's no copy and pasting into the ordinary terminal from something outside of the terminal. There are different flavors of terminal that you can get if you get into this that will allow this, but the ordinary Mac terminal simply doesn't allow it. So what we're going to do is just take a moment to input all of this. And if it takes you a second, that's fine. You'll notice that I am absolutely not the quickest typist in the world. I don't think I could actually do one of those, jobs where you have to do transcription and they pay you like, by the word or something. Feel like I would probably fail pretty miserably at that. But what this is doing is giving all of us a reason to enter all of this text in here. And remember to keep entering it on a single line, even when we kind of go over, you see it kind of goes over here. And then once you're done, you can press enter and hope that you did it correctly. And since I didn't get an error message, I think I probably typed that correctly. And when you're finished, type head, well, I'm typing type, n, and then 5 genesis.hist, and you will get, in alphabetical order, some frequency lists of the words in Genesis, or in this fragment of Genesis. Notice that Abel appears 9 times, but this guy named Abimelech appears 24 times. Possibly something you didn't expect. So the cat command, which means concatenation or joining together, actually will give you all of your frequency lists. So if you type cat genesis.hist, you'll get a full list, but this will fill up your screen and I'm not going to do it. So word of warning, you do this, it'll fill up your screen. Head is a much kinder option to your screen. So what did we just do? So here's kind of the important part. This is a little analysis of this long command. So tr, which is the first command, means translate. And it means translate in the etymological or literal sense of bringing across. So replacing one thing with another thing. It replaces the first argument, And these arguments are in single quotes. Notice these single quotes here. So we'll get to what this -sc is in a second, but for now we're talking about this argument. Arguments, again, are in the quotes. So it replaces the first argument here with the second argument. And I will tell you what these things mean in a second as well. But first, after the dash are command options. And -c means the complement. So what this means is, rather than specifying that you want to replace everything in this first argument, what you're saying is you want to replace everything that is not in the first argument. So what is the first argument then? That seems to be an important thing if we're going to be replacing everything that isn't the first argument. And what the first argument means is, in these brackets, we have A to Z, which stands for all capital letters. And then next to it in the brackets, we have A to Z lowercase, which stands for all lowercase letters. So if we were to do this without -c, we would be telling it to replace all letters with this. And what's this? So what this is the ASCII number for a new space. And ASCII is a type of computer encoding, even in Unix, even in Unicode and in other types of computer encodings, everything is in a computer communicates with the computer through a number. So each character has a number associated with it. And this is the character that stands for a new line. So yes, new lines are considered characters. So what we've done here then is we've said replace or translate everything that is not a letter into a new line. Now, notice how this works. What we've done is we've gotten each individual word on a separate line. And this is because one of the things that is not a letter character is a white space. And each word is separated by a white space. So words are separated either by white space, or they're separated by punctuation, such as a comma or a period or something similar. And this command translates all of those things, all of that punctuation or white space, into a new line, which means that each word then ends up on a new line. So that's fairly cool. You can also, instead of using the ASCII number here, use this \n, which means new line in most modern Unix systems, but not all Unix systems are capable of doing that. So I used kind of the older way of doing it here, which should work on all of your systems. All right. So the S in after the dash in translate means squeeze. It means if there are multiple instances of non-alphabetic characters next to each other, so white spaces or punctuation or whatever, don't add a new line for each of them, but only one. So if we have multiple lines of white space, or if we have ellipses, meaning multiple periods next to each other, we're only going to translate that sequence into a white space once, because we don't want a bunch of white space, in successive lines. So very, very importantly, when we're talking about manipulating data and using data, and let's get away from this. I don't know why it's there. All right. So we're talking about manipulating and using data. Notice how we have this little sign here, which is these greater than or equal or greater than or lesser than signs. next to genesis.txt. What they stand for are little arrows that tell the program to take data from one side and put it onto another side. So here, this arrow is saying, take data from genesis.txt and use it for the translate command. So it's taking all of the text in genesis.txt and using it for this translate command. And you can also use that in order to create files. And we've done that at the end here. So what we've then done is say, take all of the data that we've just created using all of these commands and send it over to the file genesis.hist. So these, you can think of these as arrows that send data in a particular direction. Another thing that's super important is this vertical bar. And the vertical bar is called a pipe. It connects the output of one command to a subsequent command. So for example, what we've done here is we've used the data from genesis.txt for our translate command. And remember, that means take any non-alphabetic character, translate it into a new line. Then what we're going to do is we're going to send that data with a pipe. So think of a pipe as another thing that sort of sends data in a certain direction, but a pipe always sends data to the right. So it sends data to a new command from a previous command. So it sends this data to sort, which then sorts the data. And then it sends it to this unique command, which then removes any sort of duplicate words. And then in doing so, it counts those words. And you do that by using the -c argument for the new unique command. So again, these vertical bars are pipes, and pipes set up a pipeline which allows you to link multiple commands together. And again, sorts things alphabetically. Unique collapses multiple instances of the same word. I see in the chat, Ulbison says terminal couldn't find the command. Which command couldn't it find?
That big string that you illustrated on the previous slide.
The whole thing?
Yeah.
So that just means that there is some part of the thing that you entered that is not correct, which is, you know, it's a big command, so it's easy to do that. But it should, if you're in a Linux terminal or a Unix terminal, it has all of these commands. All right. So how do we know to use these different commands or you know, to use these arguments or to use these, you know, options? And when we're using these dashes, what we're saying is we're giving it certain options. So you can read the manual, and the manual can be accessed by using the man command. So for example, you can type man sort, and we get, you know, a lot of text. And if we don't want to read all of it, we can type Q and get out of it. So if you did persevere, though, you would notice that if we wanted to see the words with the most number of hits, so those words which are the most frequent in our genesis.hist, -n sorts by number. So instead of alphabetical order, we can sort by number. And -r sorts in reverse order. So we'll see the biggest numbers first, which gives us the things that are most frequent, or the words or tokens that are most frequent. So what we want to give our sort command is -nr as an option. It's important to note that we don't want to get rid of our first sort. So we need that for the unique command to work. So what unique does is it takes all words that are sorted together and collapses them into a single token. If they're not sorted together first, then the unique command does not, actually function. So this time we're going to use a pipe in order to send the results to another file. But rather than just view the first 5 results, using head, we're going to, pipe it over here. So we don't actually, because we already entered this command, we don't actually have to enter it again. We can use our up arrow keys on our keyboard in order to access commands that we had previously entered. So if I do the up arrow, I can go back to man sort, I can go back to head n5 genesis.hist, or I can go back to my long command that I just did. Now, in order to change this, you can use the vertical arrows. So you can't use the mouse to do this. You have to take the cursor with the vertical arrows and move it around. So here we still want most of this, or almost all of this. We still want sort, we still want unique C, and I'll put this better on the screen here. We still want unique C. But then after unique C, we could add a pipe, and then sort nr, add another pipe, and then head, and then n5. So we want to see the first 5 results again. And we're not going to send, because we're only seeing the first 5 results, we're not going to send this to a new file. So we're going to remove the greater than sign and genesis.hist, and then this should give us what we want. And as you might expect, this gives us, the article as being the most frequent word, followed by the conjunction and. And for those of you that are into computational things in linguistics or the humanities, you'll note this is a good example of Zipf's law, where we have, the first ranked thing as being extremely common, and then gradually and the second ranked thing being very common, and then things just kind of gradually drop off. All right, let's move on. And let's play around a little bit. So stringing together commands with pipes is called a pipeline. It's super useful, and you can do almost anything with it. So let's say we wanted to know the most common vowel sequence in Genesis, or the most common vowel sequences in Genesis. So let's do this command real quick. And again, you don't have to, you can type in the whole thing if you want, and I'll make sure that this is out of the way. Or you can kind of take the command that we just used, and we won't need this, but we can keep this stuff. And what we're going to do is we're going to keep our TR. We're going to remove SC. And then we're going to have A to Z. So we're creating different arguments here. And then removing this stuff, created this little, let's see, all right, there we go. And then creating a new translate or TR command here. And I will explain what this all means in a second after we're done inputting this. There we go. And, oh, I've forgotten to add a pipe there. There we go. And we should then get a list of all the different vowels, and I'll explain what we've just done. So what we've done is, in this command that we just created, is we replace lowercase letters A to Z. So we replace lowercase letters or with uppercase letters. And we do that by using all the data in genesis.txt. Then once we've gotten all uppercase letters, we do another translate command, and we replace everything that is not a vowel with a line. So essentially, we are deleting every single character, including punctuation, but then all alphabetic characters, every single character that is not a vowel, and replacing it with a new line, which is how we get this sequence here. Then once we've done that, we sort it, we delete any sort of duplications and count the number of duplications before they're deleted. And then we sort it in reverse numerical order. And we can see that the most common vowel is E, followed by A, and then O, and then I. If we were being, exhaustive in our vowel count, I may have included Y as a potential vowel, but it's also a consonant, so I've left it out. I've snubbed Y. So what if we wanted to sort words by rhyming frequency? So we can also do that. And do this. And this time, let's go back again to our original command. And note here how I have, let's make sure that I'm not blocking this here. Notice that I have used a left dash or slash n here, or backward slash n here, but I don't have to do that. I can keep this in my, ASCII character as well if I want. But we can keep all of this, use the data from genesis.txt, then use the reverse command to reverse all of the words. So turn around all of the words that we're putting on separate lines with our original translate command. Then we'll need to sort it. Then delete duplicates and count. And then see, reverse. And then we can do the head if we want, but we don't have to. But let's do the head. Let's keep the head. I don't have that in the PowerPoint, but let's go. That's not very good. Let's go. Let's actually remove this and let's get the whole thing in its glory. And you'll note here that in this, it's filled up my screen, but it's fine. We don't need it. But what it's done is it has given us this in more or less rhyming order. So organized by the ends of words rather than the beginnings of words. And the way that we've done that is we first took each word on a new line and reversed it. Then we sorted it without any argument, which means it's in alphabetical order. So we sorted the reverse word in alphabetical order. Then we used the unique command on it, and then we reversed it back to its ordinary order. So that is one way you could do a rhyming dictionary or a rhyme frequency dictionary. So another thing that we can do simply with the command line is produce lists of n-grams. So n-grams are words that go together in sequence. N means how many words there are in the sequence. So a bigram, from Latin bi, and then gram meaning something written, is 2 words. So in that last sentence, a bigram is a bigram, and then also so are bigram is and is 2. So it just means words that go together and 2 words that go together. A trigram would then be 3 words that go together. So a trigram would be in this sentence, a bigram is, and then the next trigram would be bigram is 2, and so on and so forth. So knowing n-gram sequences is super useful for many research questions. It's a big part of natural language processing because a common way of thinking about semantics or word meanings, and then also syntax and the way words function, is that you will know a word by the company it keeps. So a word that tends to be with other words, similar words, means that it's more like another word that is also with those words. So to get the list of words in Genesis, we already know what to do, which is this, translate thing. And what we can do here is create a new file. So here, let's go back to our original command and then delete most of our pipe because we don't want to do any of this sorting or counting or anything like that. We want all of the words in all of their glory. And then remove .hist and add .words. So as you can see, command here is the same as we did before. And we can just get a list of words and then use, I think I've added an extra space there, there we go. And then we can use this greater than sign or arrow to move it to the new file genesis.words. And that works. And, now that we have that, we have a list of words, but then how do we get the words that are immediately following or subsequent to the words in our word list? So we already saw how tail is used to see the last lines of a document. So if we used man, and I will give you this, I'm not actually going to bring up man here because that will take too much time. But if we used man, we might see that we can use the plus addition to tail to output everything but the first few lines. So let's see what I mean here. So the command that we're going to use here in terminal is tail +2. And then we'll use our word list, genesis.words, and send that data to genesis.nextwords. And tail +2 means start at the second line of Genesis words. So if we said tail +1, it would start at the first line, which would be functionally the same as, normal. And the way that you get this is essentially the way the program interprets this is it's saying, go to the end and then come back around again. And +1 would be come back around again to the first line, come back, and then +2 is come back around again to the second line. And, if we wanted to see that, we could head genesis.nextwords. And notice that it starts at the second line, and we don't have in, we simply have the beginning, when God created the heaven, etc. So the paste command joins two files together horizontally. So if, say, we were to paste Genesis.words next to Genesis.nextwords, this will give us a list of bigrams. So we can send that to a file named genesis.bigrams and then manipulate it from there and do counts on it. Or we could just use it to paste the data directly. So if we wanted to get, for example, the top 5 bigrams, we could say paste genesis.words and then genesis.nextwords. Send that data that we just did to a pipe or through a pipe to sort. Use another pipe. Count all unique instances, or count all instances and then delete the duplications. And then sort in descending numerical order and give us only the first 5. And this is probably unsurprising to people that know English natively. The most common bigram in our Genesis fragment is of the, followed by in the, and then said to. And in 4th and 5th place, we have the land and the Lord. So, we have functional things which are very common, and then we have something in the 4th and 5th place that are very topical. And you can see how this sort of bigram thing might be useful for certain types of research, because if you imagine Genesis and the Bible in general, the land, especially the Old Testament, the land is quite important, as is, of course, the Lord. So how might we create trigrams using the same process? So just think about this for a second. Think about how we just did that. We just used tail plus 2 to get Genesis nextwords. How might we, go forward and get trigrams? I'm not going to let you think about it too much. This isn't a real class, but we would, of course, use tail plus 3 to get the 3rd line, and then of genesis.words, and then send that to genesis.nextwords, or maybe some sort of more elegant, file title. And I am not going to necessarily do that here, but that is how, if we wanted to get trigrams, you would do that. And you could do the same thing with, even larger grams. So cool. I was going to go over shell scripts, but I think I'm going to leave that for a different workshop. Shell scripts, I'll just say something about shell scripts really quick. If you wanted to do all of this all of the time, you could create a shell script in order to have all of this stuff together and then just use that by running the shell script. So this shell script here does exactly what we would be doing normally with these commands that we've been using. It just organizes all of the commands together. And it creates temporary files, which are represented by these $signs. And then it deletes the temporary files at the end. This hashtag here is a comment, which says what this next thing is doing. So what you would do to do that is you would use a text editor like Nano to create the file, write it, etc. But just if you're interested in doing this, research shell scripts, and this is the type of thing that you'll be doing, and you would then run your shell script with sh followed by your shell script name, and you'd send the data from some sort of text that you have. So something that I think in the short amount of time remaining is more important than telling you how to do shell scripts, which again, I highly encourage you to do on your own, is grep and regular expressions. So grep stands for general regular expressions. And these commands are filter commands that allow you to look for certain text in, a corpus or in, a string or whatever. So for example, what if you wanted to find lines with the trigram, the land of, in Genesis? So what we could do is type, and let's clear all of this out and make our thing good. So if you type clear, you can clear your shell. So you'd type grep, and then in single quotes, the land of, and then the file that you're going to be searching. So in this case, genesis.txt. Oh, let's see, there we go, yeah. Sorry, I confused myself of where I was, what directory I was in. And then I realized I was in the correct directory. And this shows us where different lines where in the land of are. So here's a line with it. It says, in the land of Canaan. Therefore, your 2 sons were born to you in the land of. So all of these are lines in this Genesis fragment that have in the land of. And there's quite a bit few of them, since we've already established that land is a big, big theme in Genesis. So note that this caret means the beginning of the line, and the $sign means the end of the line. So to find land in the land of, or the land of, at the beginning of a line, you'd type, and let's just do this. And remember, we're using the up arrow to get cans back that we've already used. And we add the caret. So we're saying, find the land of in the beginning of lines. And there's only one instance of that. So that might be more useful. You might want to say, oh, what lines actually start with my trigram? And we could, of course, do that with the end as well. So in addition to this sort of more general search that we're doing, you can also look for, very, very, very specific things with grep. So what if we wanted to look for lines that have words that end in ing? So we could use a wildcard character. So when we're using general regular expressions or regular expressions, the period is not an actual period. What it means is any character. So it means search for any character in this specific location. Then we'll also use this star or clean star, which says 0 or more of the preceding character. So let's use grep again. And here, between our single quotes, we can have our wildcard character, meaning any character goes here. Any amount of any character goes here in the word goes here. And then ing. And what will this give us? So this gives us a list of lines that have words that end in ing. And notice all of them have some word that ends in ing, for example, saying here, speaking here, etc. So we can also do this with shell commands. And again, if this were a longer workshop, I'd actually go into shell commands more. But you could do this with shell commands and find this with trigrams. So egrep is an expanded version of grep that allows more regular expressions. And what are regular expressions? Well, we already kind of used some types of regular expressions. These are POSIX expressions here. So this, as we've already seen, the A to Z between brackets means match any lowercase letter. So A to Z, capital A to Z between brackets means match any uppercase letter. And you can do the same thing with numbers. So this means 0 to 9 means match any number, so match any digit. And then we could do something like this for match any vowel. So the caret, and don't get confused here, the caret either means, all right, somebody's coming in. All right, so the caret means either the beginning of a line, or it does the same thing that -C does when you're using translate. It says the complement of the things in the brackets. So what this string means is match any letter but a vowel. So we could have used this with our translate command if translate took regular expressions, but that version of translate doesn't take regular expressions, unfortunately. The wildcard character matches any character. The $sign is the end of a line. And the clean star means any number of X including 0, so or any number of the preceding character including 0. If you have a plus, it means one or more of the preceding character, and you can only use that with egrep and not grep. And this, again, don't get confused. Remember, vertical bar, when you're talking about most commands, it means a pipe, creating a pipeline. But when you're talking about regular expressions, it's a disjunction bar. It essentially means or. So X or Y. So find me all instances of X or Y. And then you can do all sorts of things with parentheses within override like precedence rules, but I'm not going to get into that. You can look that up. So, for example, using these things, what if we want to know how many kings are discussed by name in Genesis? So what we could do is we could use grep, and I'm continuing to use grep rather than egrep. And we could say king, and then a word with any number of characters. So notice how when you're using regular expressions, you can also use white space. So you can say a word followed by the word king, followed by any word at all, really. So that has any number of characters at all. And let's see what happens. And we get all the times that kings are mentioned as King X in Genesis. We got King Amraphel, we've got King Arioch, we've got King Cordolome of Elam, King Tidal of Goyim. So we got all the kings here. This isn't even the Book of Kings, and we've got a lot of kings. So you can also use grep in order to count. So, for example, we could do exactly the same thing that we did before, but then add the C or count option to grep and see what happens. And we can see that there are 7 lines that actually have king in them. And notice how this is not actually counting the instances of king X here, because there are certainly more than 7 instances. It is simply counting the number of lines in which king X appears. So you could also pipe the first command without C to word count. So for example, you could say grep and then king, and then genesis.txt, add a pipe, and then word count L. And you would get the same sort of thing, and you'd get 7 here. And that would do the exact same thing. Now, what if we wanted to see only lines that mention light at least twice? So what we could do is we could use grep and then light, and then any number of characters. And, you know, in this version of regular expressions, this can also mean white space. And then type light again, then genesis.txt. And we can see, then God said, let there be light, and there was light. And God saw that the light was good, and God separated the light from the darkness. So all of these things in the beginning of Genesis, these lines mention light more than once. Maybe your research, you know, would give you reason to know that. All right. So there's also, you know, sed or stream editor that takes one regular expression and replaces with another. We don't have time to go over that. There's also awk, which is an excellent function, and I encourage you to look up both sed and awk. We don't have time to go over these, but this presentation was based on Kenneth Ward Church's Unix for Poets. So if you would like a more thorough version that includes exercises, I'm going to put this in the chat, and I highly encourage you to look it over. There you go. So please look that over, Unix for Poets. Another thing that you can check out is this command cheat sheets. So Tufts has this great command line cheat sheets that you can look over in order to learn this stuff more thoroughly. And then the other thing that you can do is read the manuals. And if you type man, even man has a manual. So everything has a manual. Read the manuals. They're long, but they're super worth it if you want to get good at these types of commands. Are there any questions before I let you all go?
Just one quick question.
Yeah.
You said like the just straight up line pipe a lot.
Mhm.
I'm just like, what does that like in just like layman's terms like exactly mean?
So what is a pipe?
Yeah.
Okay. So perhaps I was not good at explaining exactly what a pipe is. So remember the vertical bar?
Yep.
So the vertical bar sends data from, so to the left, we have some sort of command, and I'm going to bring up the first thing that we did. So to the left, we have a command translate, okay?
Mhm.
So the command translate takes data from genesis.txt and does something to it. And in doing something to it, it gives us output. What a pipe does, or this vertical bar does, is it sends the data, which is the output of the translate command, to the sort command. And then the next vertical bar sends whatever output we get from sending this data through translate to sort and sends it over to the unique command. So a pipe sends data along a pipeline. Does that make sense?
Yeah, it like filters it. Okay, I got like kind of. I understand what you're saying. That was a good way of explaining it.
Yeah, it's literally like thinking of like, you know, water going through a pipe, you know, that passes through different stations. So one station, like, you know, say like put something in the water, another station like puts another thing in the water, and then the, you know, each pipe passes it along to another station, which then does something else to it.
Okay, I got you. Thank you very much.
Yeah, no problem. Are there any other questions? All right, it doesn't look like there are any other questions. I hope this was helpful as a very brief introduction to the command line. Again, if you really want to learn more about this stuff, especially for text processing, I would highly recommend Kenneth Ward Church's Unix for Poets. And there's just also a massive amount of data and resources on the internet about this sort of thing. So take this information about pipes and about moving data, you know, into different files and things like that, and about the manual, and go forth and try to do your own thing with it.
Awesome. Thank you so much, Brent. That was really cool.
All right, I will see you all, you know, at some point. Happy spring.
Happy spring. Bye.
Is there so Diana, where will you be putting the recording for this? Or are you just giving this to the participants?
Yeah, I'll let you see it first, and if there's any, you know, any reason you don't want to share it, we won't. But I was thinking of just sending it to the people who registered, so a little bit more than who showed up here today.
Okay, that sounds great. Yeah.
Okay, great.
Thank you for hosting.
Yes, thank you, Brent. Appreciate it.
All right, happy spring, everybody.
Happy spring. Bye.